name is Bruno. I'm a PhD student from the University of Minho, and I'm here today to present CHERI, the implementation of CHERI on CVA6. Last time I came here to present the hypervisor extension. Now I'm implementing CHERI. So I'm going to just give a little bit of context, introduction, then I'll skip over to the implementation on the CVA6, and then I'll just finish saying where we are now and what we'll do next. So capability-based security is an old concept, and basically it's a design concept there where you use capabilities to implement security or to make privilege separation. I have here an image just showing what you can do with capabilities. Instead of having like a central that manages your access, each actor in the system has one capability. Like, for example, you have Bob and Alice. Bob has access to resource A. He can only read it. If he tries to access resource B, it will fail. So it's a more deterministic way of protecting. So about the CHERI RISC-V, I think Tariq already gave us a very good overview of the CHERI extension on RISC-V, but what can I say is that basically CHERI gives us a fine-grained memory protection because it replaces pointers for caps. And so it has also some instructions to manipulate capabilities and also some special CSRs. It's extended some CSRs. This is what a capability looks like. Basically, you still have the pointer, still have an address, the reference to an object, but you have some metadata that helps you to enforce bounds and to do some permission checks. There's also one tag bit for each capability that enforces the pointer integrity. The ISA itself also implements some instructions that helps you to guard manipulation. So if you want to create new capabilities, you cannot exceed the original capability. So you cannot make a more powerful capability than the original one. So skipping over to the implementation itself. So we had to do a lot of changes. Basically, when you're implementing CHERI, you need to extend all the registers to be capability side. We also had to change the decoder to implement some CHERI instructions. We added some logic unit to process the CHERI instructions to enforce bounds and so on. We also had to change the data cache to have one bit tag for each capability. And we also had some CHERI CSRs or extended the CHERI CSRs. This is what the features and status looks like. So right now what we have is the implementation compliant with the CHERI ISA version 9 of Cambridge. We are starting to move to the CHERI standard. We only implement the RISC-V but we plan to implement also the 32 with MMU or without MMU because the CVA6 is very parameterizable. We have the merge capability register file. We also support the two modes, so you can have pure capability code or hybrid code. We implemented the compressed capability format. And finally, we also added something that was missing on the spec, that was the hypervisor extension integration. So although they are very orthogonal, you still need to do some changes like extend some CSRs on the hypervisor extension and also extend some instructions to support CHERI. So to do some kind of validation, we had to implement a simple SOC, and we wanted to have some way to manage the tags. So we implemented a tag controller compatible with AXI. So this tag controller only manages the capability tags, and we stored, it's a very standard, we just store the tags on the top of the DRAM, a reserved space for the tags. And basically did is we added a simple IP that fetches the data and also fetches the tags, and we have a tag cache that is based on the pulp last level of cache. So I reuse some of the logic units that were already there to speed up the process. Right now we don't support tag compression because it's very simple, it's very early stage, but we do plan to have some kind of tag compression support. So the point that we are now is validating the design. We have done some test benches to test some logic units. We have something running up on the FPGA with the tag memory support and running pure capability code, for instance. We are doing some bare metal tests on top of hypervisor framework that we have. We also plan to have, we are doing this now, the test rig, the framework that Cambridge has, we are implementing this one and supporting this one. We are also porting BAU, it's our hypervisor, we are porting it to CHERI to validate the extensions that we did for the hypervisor extension on CHERI, and we also plan to run CHERI BSD, of course. So the implementation is not public right now, but it will be soon. The links are there, and it will be the same links, so probably next month I will publish everything, and you guys can give us some feedback. It will be very helpful. So I did some preliminary evaluation on FPGA on Genesis 2, on a CVA6 core with hypervisor and CHERI support, and also a tag controller. I get like 30% of increase in resource, which I don't know if it's much or not right now, but I still don't have any optimizations. I do plan to optimize the design and change some stuff as I do some analysis in performance and also in real silicon. So next steps and roadmap. Basically, we want to complete the validation because right now we just did some test benches, so we need to complete the validation and have more stable design. We are also porting about to work with CHERI or to be compiled with CHERI, and we are also plan to explore some CHERI models in the context of virtualization, hybrid or pure capability, or without MMU. There's still a lot of work going on in this area. We also plan to bump the implementation. I already started to the CHERI standard specification. It will take not too much time to complete it. And finally, we are exploring trade-offs of performance. This is a long-term goal. We want to explore, to do some PPA analysis and performance benchmarkings and so on. Our goal is to provide like an open source virtualization reference stack with CHERI support. We already did a lot of work in virtualization. We have the CVA6 running up and with hypervisor extension. It is already official. It is an official repo. We have IOMMU with virtualization support, the IAA with virtualization support, and now we want CHERI on our open reference stack. We also have a BAU. It's our hypervisor, and yeah, we have done a lot of work in virtualization, and we expect to have CHERI now and explore CHERI also. Thank you. I think that's it. If you have. Maybe we have time for questions.
So we've got time for questions.
And no questions.
Yes.
Okay. No microphone.
So what's the best way to follow your progress in this work?
Right. Right now, I don't have like official channel to show what I'm doing, but I'll probably post it on the Slack that CHERI has, and I don't know, maybe LinkedIn or something. I will try to publish to put it out there for people to use it and give me feedback, because I think it's interesting and it will be helpful for a lot of people, I think, at least from the people I spoke in the conference. Okay.
Thanks, Bruno.